So right now I'm going to go over scientific notation, what it is, how to change between a regular number and scientific notation and vice versa. For those of you that will be taking chemistry, this will be very important for you to understand in chemistry class. So what scientific notation is it's just a way of writing a number. Let's say we have a couple digits. Just imagine those 3, 7, 8 or something. Doesn't matter, those are just some spots of some numbers. It's going to be times 10 to some power, k. I'm going to call it k. So the key is, whatever the number is, we always want the decimal point so that there is only a number in the ones place. So we don't want a number in the tens place. We want this number in the ones place to be between 1 and 9. So it can't be 0 point something. Or if it becomes bigger than 9, then there's something in the tens place. Okay, so I'm going to call that, to be consistent with the handout that goes with this, I'm going to call it P. P times 10 to the k power. And P needs to be, is between 1 and 9. Now, I'm going to tell you one way of looking at this. One way I like to look at this is if you move the decimal place, I'll do a little abbreviating here. If you move the decimal place to the left, then that means you're going to increase k. K is going to go up. And if you move your decimal place to the right, then that means we are going to decrease k. Decrease k. Okay. So that's one way of looking at this, and I'll point that out as we do some examples. The other thing I would say, which for me makes more sense, is really, really big numbers. Big numbers have a positive k, and really, really small numbers have a negative k. Okay, and one thing I forgot to say earlier too, let me add this up here. K is an integer. And I'm sure everybody remembers what an integer is, right? It's kind of like whole numbers, but negative and positives. So it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, and so forth, or it could also be -1, -2, -3, -4, going that way too. Okay, so let's keep these ideas in mind. Really big numbers are positive, really small numbers are negative, negative k, and do a couple examples. So, put a page here. Sorry, one second, this is moving slow. Okay, so let's do an example of going from, we'll call it a standard number, standard notation, to scientific. To scientific notation. So let's start with a big number first. So if we have, let's say, 3,460,000. And we want to write that in scientific notation. Okay, so I have to figure out first, well, where does my decimal point go? Remember, we want just a number in the ones place between 1 and 9. So that means I'm going to want the decimal to be right after that 3. So that I end up with 3.46, and then I don't really need all those zeros. So that's going to be times 10 to some power. Okay, so what I could do, remember we said moving the decimal to the left makes k go up. So if I go this way, 1, 2, 3, 4, 5, 6, I moved the decimal 6 times to the left, so that means it's a positive 6. K went from 0, I kept going up by 1 up to 6. Also, remember I said if it's a really big number, so it's going to be a positive k. Now how about 0.0025? Okay, so I want my decimal to have just a number in the ones place. So I'm going to want it right after that 2. So 2.5 is what I'm going to want for my my number before the times 10 to the, now I have to look, I'm moving to the right 1, 2, 3 times to get between the 2 and the 5. So since I moved to the right, that means my k was going down, so down to -3, because I moved it 3 to the right. Also, it's a really small number, so I moved it 3 times, and it's going to be a negative k. Going the other way from scientific to standard notation. So let's say I have 4.9 times 10 to the 3rd power. So kind of using the same idea, if I want this to become standard notation, let me rewrite the 4.9. I'm going to move 3 times, I'm going to move my decimal place. Now if it's k is at 3 right now, I'm going to move it right to bring it down to 0, from 3 to 0. So 1, 2, 3. Now I'll have to fill in zeros in those spots. So my number is 4,900. And you can kind of go back and double check if you want. Start here, 1, 2, 3. Yep, 3 times to get between the 4 and the 9. So 4,900. Plus it was a positive exponent, so it's going to be a big number. How about 2.056 times 10 to the -5th? 2.056 times 10 to the -5th. So, let me rewrite my 2.056. So, well, I would kind of look at it and say, well, it's a negative exponent, so it's going to be really small. So I'm going to have 0 point something. So I'm going to have to move 1, 2, 3, 4, 5 times to put my decimal. Sorry for the construction interruptions, but so that means I'm going to have to put zeros in front of the 2. So I have 4 zeros in front because when I moved the decimal behind the 2 to in front of it, that was 1 time, and then another 4 times. So let me rewrite this nice. 0.0002056. So that is my number in standard notation. I also, we talked about too, moving the decimal to the left increases k. So I was at -5, now it's up to -4, -3, -2, -1, 0, which puts it in standard notation. Let's do one more real quick, just to show you the kind of the meaning of scientific notation. We use this form, but let's say I have 6.2 times 10 to the 4th. Okay, well that's 6.2 times, what is 10 to the 4th? If you do 10 times 10 times 10 times 10, that's 10,000. So now if you take 6.2 times 10,000, that's going to be 62,000. So notice, just like if we do our decimal moving 1, 2, 3, 4, I'd have to fill in 3 zeros. I'm going to erase that so it doesn't look so messy, but you can see kind of the idea. So it's when we multiply by 10 to some power, it's like multiplying by 10, 100, 1,000, 10,000, 100,000, million, so forth. Or the negative, it's like multiplying by 0.1, 0.01, 0.001, which is 1/10, 100th, 1,000th. One last kind of example I want to do. Let's say, in chemistry you might be working with a number, do some multiplying, and you end up with 65.3 times 10 to the 6th. And you have to change this to proper scientific notation. Well, we know it shouldn't be 65.3, we need it to be 6.53. So now, here's where you can kind of use either way. The idea of, well, to get the decimal from After the 5 to before, I'm moving to the left, which means I'm increasing my exponent. I moved it once, so it would go from 6 to 7. The other way, I personally get confused with this sometimes, so what I do is, even if it's just in my head, I don't even jot it down, I think, well, I'm going to go 1, 2, 3, 4, 5, 6, make it a regular number, and then I'm going to go back 1, 2, 3, 4, 5, 6, 7. So I kind of just change it to standard, back to scientific if I'm getting confused, especially with the negative exponents. So that's one way to do those. And that is about it.